Okay, tutorial number 3. This is the second take because the first one is kind of long. Oh yeah, and I forgot to increase the font size for y'all. Okay. All good. No hurry. I'm just gonna make this easy. So we're back to mednafen. Remember last time we figured out that address that had the seed in it. So just run and see if you can see the window. So start out with just showing the window. There it is. Okay. So I control it so we can start up a game, right? We're gonna pause it just like last. Whoops. So this is the wrong level. We want to switch to level 8 so it's nice and slow. So yeah, we'll pause it here. No big deal about where I pause it. And if we do Alt-D, whoops, Alt-D will bring up the debugger, which is too small for this view, so we'll make the debugger view a little bit bigger. It's not, it's still not that visible, but we're going to see that it's running, and we can see this value here, which we're really interested in, this seed value. The seed value is increasing every frame, pretty much. Like, there's some asterisk there, but like you can see this value is changing and this value is changing, but this value, you can definitely see something's going on there, and we know a lot about that because we reverse engineered Tetris Gym. We actually have the source code for Tetris Gym as well. So we have a lot going on here for us, but in this one we want to write memory to this running process. We can do that with GDB. We can also use mednafen's poke if we pause. Yeah, if we just pause it here by setting a breakpoint right where it's running, and then we do P, it'll give us this poke address value size, and we can like pick the address 0, and then the value 10, and then the size 1, so it's 1 byte, and it'll be hex 10. And we can see that that went into byte 0 there. And I don't want that to be true, so we're going to poke again, value 0, size 1, right? So there we go. That's how you do that in mednafen. Let's go ahead and take a look how you do the same thing in GDB, which is what we're trying to teach. So first off, we make the debugger invisible, we make mednafen invisible, and then Control C, just like we did before. And then remember how we did info threads. This really isn't necessary, right? Because memory is memory no matter what thread you're on. But you can see thread 15 is the one that we care about. If we do a backtrace, we can see CPU callback, debugger fudge. All of this is stuff we want to happen, right? And we're paused, and this thread is like totally cool. Let's go ahead and read the memory. So the very first thing is we know the address because we had it last time, but let's go ahead and type that character by character so that y'all can remember it. x/16bx, right? So write 16 hex bytes and then give an address. So that address is 555556b2bf, and then 28 would give us the 8th, and we want the 0th, right? So if we take a look, 0029C, and you'll have to believe me that it's 0029C at the start, unless you want to rewind. I don't think you really need to rewind to see that I am not lying. And you can see that this name here is, the C++ version of medfen underscore ien underscore nes colon RAM, right? Okay, so next up, right, we want to write. So we have this command that I've got here in my script. Unsigned char gives us unsigned char in C, which is 0 through 255 are the values. And then we just give it the right address. And I'm just going to copy and paste because I don't trust my typing. And then equal to, and then we give it a value like 33. And that's all you have to do. If we go back, if we set continue, then it's in this pause mode, so it's not going to be writing or reading. So we're in good shape there. You can not see it there, so we'll bring up the debugger, and you can see 33 in the first slot. Let me point to it, 33 there. So that was caused by us doing that in GDB. I'm not actually sure what, oh, that's a temp variable. So yeah, this I remember this being temp1 in GDB. So it doesn't, it should not cause any problems being there. But we don't want to test our luck. So we're gonna put this away and we're gonna write again to undo the change we made. See, Control C, set unsigned car, 0x0. And that should fix it. We only even have to go back to mednafen to check because we know how that works. So let's score some points, right? So continue, and then we bring up mednafen, and then I'll undo the break, and yeah, grab the controller. Oh, it's paused, so we don't have to worry about that. So we, oops. R to run, Alt D to get rid of that, and let's score some points. We can push down. There's 5 points, there's 7 points, 10. We want a little bit more, so let's burn. And here's a double. Cool, so now I have 941 points. And if we open up the debugger, zoom in, you can see 09 there, and then 41 there. So that's the decimal representation of the score there in these 2 bytes, and it's backwards, right? Now if you look to the left, something else going on here. Curious what that is. Well, if we go back to our GDB, we can type in 3AD. See what 3AD is in GDB. Oops. Yeah, okay. So we can actually open up another terminal, run Python. See, it's 941 in hex. So we can go back to our debugger. We look and we see 3AD, and it's backwards, right? So it's little endian, right? So the 3 is there, the AD is there, which means that if we modify these values, we should get a different score. And that's what I found out after working through it, so you don't have to figure it out. So if you modify these, then your score changes. So let's go ahead and go back to GDB and do that. Like 2 debuggers going at the same time. So yeah, the offset that I found it to be was 2829 to A. And if we, yeah. Weird. Yeah, I just, I will never understand the addresses, so we can just accept that. And we can do set unsigned char, right? And then this is 28, and we want that to be C4. So that is our highest, I think. And then 29, we want to be AE. And then 20A, remember we're in hex, so after 9 comes A, not 0. We want A. It doesn't really matter this lowest byte, but we'll figure that out later. It just now occurred to me that this could be the lowest, this could be the middle, and this could be the highest. What would A, AE, C4 be? Okay, so that is true. So 700, 100 is what I wanted to put in. So this is the highest, and this is the next, and then this is the lowest, right? Middle, lowest, highest byte. We do continue. Here we are in our debugger. Nothing has changed because we're still paused, right? And grab our controller. Oh, and you of course can't see that because, there we go. Okay, so you can see that it's changed here, but not in the game. Not in the game because we have not unpaused. We have not scored any points. So we let that drop, and 700, 100. So there we go. We're in control of memory of the running process, and it doesn't know any better, right? It's not correcting us. It's not, setting any flags. It's not like cheater alarm, because this is NES. You're not checking to see if a person has modified memory. So yeah, no need to play this out because we control memory, we control the score, we control the piece sequence, we control everything that we really want to, and really all we want is for T pieces to fall. And you might think I pieces are better, but yeah, kind of fan of T pieces. So that's what we're gonna do. I actually didn't figure out how to do eyepieces. We could, mess around, but I kind of want this done. So, remember how we did a watch in the previous one? Well, we're doing it again. And we're trying to remember if we take this, remember that the seed was at 37. So we're going to watch that value. And we're going to automate that breakpoint. So we've got a hardware watch point of writes to memory. And then we are setting a command to run then, right? And we can do set. And instead of writing to the score, which isn't going to help us, we want to write to the seed. So if we do 37 equals, and I'm not sure if this byte does anything, because it doesn't seem to, it doesn't seem to affect the outcome. But if we do, then the next byte, 38, and my enter key just came right off, no big deal. Oh, yeah, enter keys, man, how they work. 39, set that to 0, and then continue, and then end. So that's our command, is it's going to, set these values, and then continue, and then end. So if we do continue, you can see all these pop up, and you can see that it's just going, because every frame hits that breakpoint twice. So now the next box goes wild because we are modifying and we get T pieces. So that is kind of funny. Can you survive with just T pieces? I figured out yesterday that yes, you can, even with no next box. And I think that's all I got for you. I don't want to play this out because obviously that's a waste of both of our time. Pause and pretty much proof. Oh my gosh, you didn't see it. You didn't see it. That's sad. But yeah, here I will show you just to prove. Nice. Indeed, all TPSs caused by that code that we just wrote, the commands 1 and then writing to memory, and we're writing to the seed, and the seed is totally messed up by that, right? It's like confused as all, you know what? And there we go, T-pieces. You might think like, well, okay, what about eyepieces, right? And the thing is that it's all controlled by the NES code, right? So all you have to do is figure out how the NES code works, and then you get eyepieces instead. We'll do that another time. Yeah, no hurry. And can we get back to the point where it wasn't? Yeah, I think we can. I think that's worthwhile. So once you set up commands, let's take that away. You can always Control C and then do commands 1, right? And then end. And you can see that it's not running our commands anymore. If we disable that breakpoint, then you have normal game, right? And let's see what happens, right? Get our mednafen, and then unpause. Gotta be prepared. There we go. And normal RNG, just like nothing ever happened. And y'all got to see it, and we can put the commands back. If y'all are interested, I don't think y'all will be interested. You saw that we got a T-storm because we added those commands to that breakpoint. And so now the next step is going to be figuring out the next thing, because we do have things that we want to achieve, and that is gonna be next time. Dynamic reverse engineering with Java T. Episode 4. Look forward to it. I will do my best. Good luck on all your projects, GDB or otherwise, and we'll see you next time.